All right, so let's pick a simple one here. Scroll on down to see what we got. You got the bowling game, you got Fizz Buzz, Game of Life, leap years. Um, guess any of those would be fine. So
Leap years?
yeah, let's see what leap years is.
Okay.
And return true or false depending whether the input integer is a leap year. It's divisible by 4, but it's not divisible by 100, but it's divisible by 400. Okay. So yeah, let's give that one a try. That should be simple. We should be able to get that done quickly.
Okay.
Let's say next. Unless you want to do it in C++, let's try Java. JUnit. Java
J.
18 JUnit.
Okay.
Solo. All right. Excellent. Excuse me. So you see how this works, right?
Okay. It is on creates new traffic light ransom test fee. Okay. Okay.
Okay, so close this. So here's our instructions. That's in the README text. You see on the left, it's got the list of all the files. You got README, you got Hiker and Hiker test. Okay.
Okay.
So here's the rules. So we can come back to that. Now let's see how this works. So you can go to hikertest.java and you can see that it's going to do life, the universe, and everything. And the answer expected is 42. And so we run the test. To run the test, you click on the big old test button in the left. On the upper left part of the window, it's got test. Click on that. Okay, so it says that it expected 42, but it got 54. Okay, so that means that there's a bug. So let's go to hiker.java. That's the test. So we're expecting 42. Let's see what hiker is doing. So you go to hiker.java. And so you see it's doing 6 times 9. 6 times 9 is not 42.
Yes.
Let's change that to 6 times 7. I bet that will be closer to the answer. So, and then we'll run test again. And okay.
Okay.
Everything's okay. So the test passed. So this is how this Cyber Dojo works.
Okay.
All right.
It's really cool.
Yeah, it's really nice.
Okay.
So let's go back to readme.txt.
Okay.
All right. And so we'll see here. So we write a function that returns true or false, depending on whether its input integer is a leap year or not. Okay. That's very clear. So let's go ahead and we will write a test. We'll call this leap year test.java. So over there underneath the test button, it's got a plus and a minus. Click on the plus. That will create a new file. We'll call it leap year test.java. LEAP. There we go. Okay. So then we'll say, let's go to hiker test. .java. And we'll just copy what they have in here, at least the imports and everything. Yeah, copy, and then paste that into leap year test. There we go. All right. So this will be, instead of hiker test, make that leap year test. Okay, and instead of life, the universe, and everything, we go back to readme.txt. What it needs to do, we want to write a function that returns true or false depending on whether its input integer is a leap year or not. So we're going to be creating a function that says is a leap year. Okay, so great. What we will do is go back to leap year test. So we'll call this what's the first thing we would want to do to see and it tells if it's a leap year or not.
Okay.
We'll say we know that this year, which is 2022, is not a leap year. Okay,
Yes.
so let's create a function that says that call it, this year is not a leap year. Okay, and so our expected will be false. Boolean expected equals false. Okay, int actual, so we'll say Boolean actual equals leap year. Um, yeah, I'm sorry, not true. Say, we'll say class leap year, so it'll be capital L for leap year.
You see, it's a class.
I'm sorry.
It's a class
Yeah,
here.
we've got to create a class to do this.
Okay.
Well, we can make it static. We'll just
Okay.
say leap year dot is leap year. And then we'll pass in a number, 2022. Okay. You can get rid of the T there. So that should be is leap year, not it's leap year.
Okay.
Yeah. So, all right. So now we run this test. And it's going to say, what the heck is a leap year?
Yeah.
So we've got a failing test. So let's make the test pass. So
Yeah.
we need to create a leap year object, create a new file, call it leap year. Okay. So class leap year. Yeah, public class. Okay. And it has a static method is leap year.
Okay.
And so we will, it needs to return a Boolean.
Yes.
Return a false.
Just for now.
Yeah. And we don't need this other function.
Don't need it. It's here.
Yeah. Go ahead and delete that.
Okay.
So we need to, on line 3, you need to see public static Boolean.
Yes. Excuse me.
That's okay. Yeah, the thing is, on Cyber Dojo, it doesn't go and do all the
Autocomplete.
stuff for you that your IDE will. So,
Yeah, no, it's good. It's good. It's a good
okay.
thing.
Yeah. So this should pass. So let's go ahead and run our test again. Okay.
Okay.
So so let's come up with another test. Well, let's go back to README. And we've got leap year is one that's divisible by 4, but not otherwise divisible by 100 unless it's also divisible by 400. Okay, so let's go to, let's go back to leap year test. And let's create a new test. You do that just by copying this. Say test leap year is not, say what, 2004.
The name of the test.
Yeah, we'll call this, yeah. We can just say test 2004 is a leap year. On line 15 there, yeah.
2000.
Yeah, but you can't start with the number, so we'll just say test
Okay.
2004
Just 2004.
is a leap year. So expected is true. Is a leap year 2022. We'll make that 2004.
Okay. Can I run a test?
Sure. Expected true, but it was false. So we have our failing test. This is a good thing. So let's
Yeah.
go back to leapyear.java. So now we need to add some smarts.
Yes.
So our first rule is that it has to be divisible by 4, right?
Yes.
So how do we make something divisible? How do we test if something's divisible by 4?
Make a module. It's
If year,
yes.
and then you do a percent
Yes.
4 equals 0. There you go. Then we will return true. Otherwise, we return false. Okay, so go ahead and run the test. And we're green. Very good.
Yes.
Okay. So then we should say next thing is it's not divisible by 100.
Yes.
So we would say 1900 is not a leap year, right? All right, yeah, 1900 is a common year.
Yeah.
1900, right?
But it's not outside divisible by 100 unless it's also divisible. Ah, okay.
Okay, but it's got
Okay. But
examples down here. 2001
our
is a typical common year. 1996 is a leap year. So we didn't use their test examples. I've been using
uh,
my brain to come up with examples. We can use theirs. 1900 is a common year. 2000 is a typical leap year. So 1900 should be false.
okay. Uh,
Okay, so if we test that, it should fail. Expected false, but it was true. All right, so let's go back to leap year.
okay.
So if it's not divisible by 4, then we return true. And we can say if it's not divisible by 100, we return true. Well, actually, we'd have to put that before divisible by 4, wouldn't we? I'm just saying that we can
See.
go try it out. Go ahead and leap year.
Yeah, yeah, okay.
We want to add if year div 100 equals 0, return false.
Okay.
Okay, so this should work.
Yeah.
We're in green. Very good.
Okay.
So then we go back to README, and it says that 2000 is actually a leap year. So let's go back to our leap year test. Normally, 2000 wouldn't be because it's divisible by 100, but it's not divisible by 400. So let's go ahead and add the new test. Test that 2000 is a leap year. This should fail.
Yes.
Right, expected true, but it was false. And the other tests continue to pass. So this is good. So let's go back to leap year. So I have to add another check that if it's divisible by 400, then we return a true.
Okay.
And everything's good.
Yes.
So that was a very, very simple exercise just to help you to learn how this tool works and to go through the exercise. You see what we did? Let's go look at our tests. So we've covered every rule in the README, right? So it's if it's divisible by 4, if
If
it's
it's
divisible by
mm,
100, divisible by 400, because it's you know, we want to have a test to exercise every rule just to make sure that we're covering it properly. So we've got our regular year, we've got our leap year, we've got our 100-year exception, and then our 400-year exception. So
yes.
got them all. So now we're confident that this covers all the cases.
Yes. It's it's interesting.
Mm-hmm.
Yeah. So it's here. Uh you first you create the the test uh, that fail. Yeah,
Yeah,
after you 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 create the all the scenarios the test.
correct.
Okay. Okay. Understand.
All right.
All right.
So let's go ahead and we still have time. Let's try another one. This is a good thing to practice. So we'll do create a new.
Yes. Yes. I will write uh during the week.
Okay.
It's very interesting.
Um, I don't know any of these would be good. Balance parentheses closest to 0. I don't know what is closest to 0. That sounds
Close to zero.
interesting. Given a list of integer, find the closest to 0. If there's a tie, choose a positive value. That's too small. Um, 8 queens. No, that might be a little too much. Let's try the bowling game is
Bowling game. Okay.
that can be kind of complex too. But it might be a fun one to try just to see.
$100.
Anagrams. Okay. Generate all the potential anagrams of an input string. That looks. Let's try count coins. I think that would be a
Count
little
coins. Okay.
complex. So basically, there's 4 types of coins in the U.S. currency: quarters, dimes, nickels, and pennies. 6 ways that you can make change for 15 cents. You have 1 dime and a nickel is 15, a dime and 5 pennies, 3 nickels, 2 nickels and 5 pennies, a nickel and 10 pennies, or 15 pennies. How many ways are there to make change for $1? So we can have a function that makes change. Does that sound interesting?
Yes.
All right,
Yeah.
let's give it a try. Okay.
Mm.
Okay, so basically we need to return the number of ways that you can make change. That sound good?
Yes.
All right, so let's go ahead and we can write a change test. Well, first let's go ahead and get the hiker test working, right? Or well, I guess it doesn't really matter. We can
No. Yeah.
so you can either rename this or you can
Are you
create a new
create
one.
a yeah.
Yeah, create a
Uh
change.java, change test. All right, we'll call this pennies equal 1, or pennies are, oh, yeah, pennies have one solution. 1 penny is one, yeah,
N is equal one
yeah.
$1.
No, well,
No, just one.
first, what we want to do is say, okay, if I've got 1 cent, then
Ah,
there's only
okay.
one solution.
Okay. I understand.
So 1 cent equals 1. So expected is 1. Actual, and this won't be hiker.answer. We'll say change dot,
Change here.
go back to the test.
Okay.
We'll call it, we're going to call the class change instead of hiker
Okay.
because we're going to see making change. Okay, then you need to rename the file. Otherwise it won't compile.
Where?
There.
No. I think it's can
Can you double click on that? Yeah, there you
now
go. Okay,
rename where? Yeah.
there you go. Call it change.java. Okay.
Uh, is Penny?
We can call it answer still. That's fine.
Ah, okay.
And it will return. You need to have a failing test.
Okay.
Or return a 0.
Okay.
There we go. Now you'll need to remove the hiker test.java. Click on that and then click the minus. Otherwise, it's going to throw an error that there's no
Okay.
hiker. Okay. All right. So let's go ahead and run the test.
You think is not equal 1, or I can less?
We need to start with the failing test.
Okay. Uh, okay. It's true.
So
It's
not hiker.
change.
Change.answer. There you go. Expected 1, but was 0. All right. So then let's go back to change and have it return a 1. And then we should have green.
Okay, it's right.
Okay. So now let's write another test. And we'll say, so 5 cents gives us 2 solutions, right? You can either have 5 pennies or 1 nickel.
And it's
I'm just building up solutions based on the coins that we have,
okay.
right?
Okay.
So penny, if you got 1 penny, you got 1 solution.
Yes.
If you have 5 cents, you got 2 solutions. So it can be a nickels or pennies.
Okay.
So let's go to change test. We'll have a new test. Say 5 cents equals 2. Two, right? So expected is 2. Now this test should fail.
Yes.
So what we're doing is we're building this up little piece by little piece to make sure that
Yes.
we're covering everything.
Yes.
Tiny steps. They expected 2, but it was 1. So let's go back to change. And now we know that if we've got a nickel, we can have either a nickel or a dime, a penny. So answer needs to take a parameter, doesn't it?
Yes.
So let's say answer, we'll pass in the int, and call it whatever, cash. And we need to, this will break our test because we're not passing anything in.
Yes.
So let's go back to change test. We'll have to comment out the test below. Change answer. So you don't want to refactor unless you've got all passing tests, right?
Okay.
So so we'll need to comment out the test on the bottom, lines 14 through 19. We need to comment those out.
Yeah. Oh. Okay. Okay. I don't understand.
So lines 14 through 19, we need to comment out that code so that it doesn't run, because we're now refactoring the program.
Yes.
So we don't want to refactor when we know we've got a broken test already. So we know that the second test is broken, but we know the first test is working.
Yes.
So what we want to do is we want to go to, go to line 13 and put a slash star.
14. Okay.
Line 13.
Oh, yeah. Excuse me.
Do a slash star. And then on line 19, put a star slash. There we go. All right.
Okay.
And now we can put the change, the pennies, what is it? Change that answer, and we need to pass in a value, right?
Yes.
So we pass in 1. Change answer 1. And then we can go to test, and that should be green. Okay, good. So now we go back to change. I'm sorry, change test. And now we put in our breaking test again. So you get rid of the slash star on 14 and 20, right? And now if you run a test, it should fail.
Yes.
Well, it'll fail because we didn't have the parameter first.
Yes.
So you need to put in a 5. Okay. So that expected 2, but it was 1. Okay. So let's go back to change. Now we say if we have a multiple of 5, then we have to see how many multiples of 5 we have.
Yes. Uh,
Okay.
okay.
And we want to return if it's a multiple of 5.
You return.
We'll have that return a 2.
Okay. It's true.
Okay. So let's try the test. And that passes. Great. So now let's go to change test. Now, if I have 6 cents, we can have it as 6 pennies, or it can be a nickel, right? So we've got 2 solutions. So 6 cents equals 2 as well. So let's add a new test for 6 cents.
Just 5 cents equals 2.
6 cents equals 2 as well.
Oh, I just to understand 5 cents.
So
Okay, nickels.
5
Okay.
cents is a nickel.
Okay, well, yes, yes.
Yeah. Should we do this with Brazilian money? Since, well, you're not in Brazil though. You're in Canada, right?
Yeah.
Well, then you should know this. I got the same denominations as we have in the US, though.
Yeah, yes. It's different.
Okay. So, yeah. So let's go back to the change test. So you got, so we want to say 6 cents equals 2 as well. Okay. So it changed it on line 25, changed that to a 6. Let's run the test. That didn't work.
Yes.
Well, let's go back to change. See, what did we do wrong? Well, 6 is not evenly divisible by 5, but it's at least 5. So it has a multiple of 5 in it. So how about we see how many divisions of 5 we have. So so if so we can say, how do we get the remainder?
And you mean?
So cash div 5 does not equal 2 if you have 6. Cash div 5 equals 1,
Yes.
right?
Yes. Uh, it's okay. 6 cents divisible by 6.
That,
No.
oh, that actually, I'm sorry, that gives us the remainder. That tells us how many times. So basically, cash div 6 would equal 1, right?
Yes.
So So what we can do is say, you want to know how many nickels we have.
Nickels, it's cents. Okay. Uh,
So you'll say, I mean, yeah, we can put in an answer for every single number we put in there, but we need to, so we'll say cash div 5 is our nickels, right? So you want to see if cash is greater than 5, then we want to start looking at nickels. So if it's greater than 5, then we'll need to calculate this.
okay.
So you've got a solution. If it's less than 5, there's one solution, right? Because it
Okay.
would just be pennies. If it's greater than 5, then there's at least two solutions, right? Because you can have nickels plus nickels and pennies.
Okay. Yes.
So if cash is equal to 5, then there's two solutions. So yeah, so greater than or equal to 5, then we just return a 2.
Uh, 2.
Yeah, because there's two solutions. We don't have to go and calculate every solution. We
Okay.
can if you want to.
Okay. Understand now.
Okay, so let's go ahead and run this test and see what solution we get.
Uh, you think it is? You can do this.
Okay, so go ahead and run the test. See if that gives us the right answer. Okay,
Okay.
now we handle 6. What's our next thing we need to be concerned about would be a dime, right?
Dimes.
So
Yes.
that would be 10 cents. So 10 cents, you've got either you can have one dime, or you can have 2 nickels, or you can have a nickel and 5 pennies, or you can have 10 pennies. So
10
there's 4
pennies.
solutions when you get to dimes.
Yes. Okay.
So,
Okay.
so we'll have a test, say 15 cents equals 4.
15.
15.
Okay.
I'm sorry, 10 cents equals 4.
Okay.
Sorry.
No, no, no problem. Não tem cents, não tem. Tem cents, okay, it's correct.
Expected is 4. We'll get the answer for 10. We'll go ahead and run our test. Go ahead and run a test, see if we've already got a solution for it. And scroll up. Yeah, run the test.
Okay.
Okay, and we have a failing test. This is good. All right,
Yes.
so 10
All right.
cents equals 4. So now let's look at change. Now we can go to
It's that. It's 10 cents.
if cash is divisible by 10, if it's greater than 10, we know we can start looking at dimes.
Yes.
So we'll see how many 10s we got in there.
Cash is greater. No, is just. Okay.
Okay, there you go. So if it's divisible by 10, so if it's a dime, we know we have 4, right?
Yes.
Okay. On line 10, we can make it a 4.
Uh, okay. Times 20 equals. Okay.
We want to come up with the simplest solution that
y-
passes the test, right?
okay.
That's divisible by 10, which means it's a dime. We know we just figured out that there's 4 solutions, right?
Yes.
So test that. I bet it passes. Oh, expected 4, but it was 2. Wait a second, what happened there? Go to change. Oh, well, because it is in fact greater than or equal to 5, so that will return a 2. So
Yeah.
it's like we need to put this check before.
Yes.
Now let's test it. Okay. So let's try 11 cents. So what do we have for 11 cents? We have a dime and a penny. So that's one solution. We have a nickel. We have two nickels and a penny. So that's two.
Independent. Yes.
We have a nickel and 6 pennies, which is three solutions. Or you have 11 pennies, which is four solutions.
Yes.
So if you have 11 cents, we should have four solutions. Change the number on 38 to 11. Let's run our test. Well, here we go again. Let's divisible by 10 gives us a 0. Well, yeah, okay.
Hmm.
Excellent. So you see the tiny steps that we're taking here, right?
Yes. Yes.
And we're
Yes.
getting to a greater solution. And this one's a little bit more complex, but it's a little more interesting to solve.
No, it is, and uh, I understand better the construction of the solution.
Okay.
How how you say, how did you say, it's tiny steps
Yeah. Tiny
to the
steps, and you make the test fail, and then you make it succeed.
make succeed. We
And
Yes, yes.
the smallest solution that will make the test pass. And sometimes you'll be surprised that that's enough. So so I will need to get going here, but what I will do is I'll let you continue through this and see how many ways are there to make change for $1.
Okay,
And we'll look at this next week when we get together. Okay.
okay, okay. It's I can I share this link?
Yeah, I've got it. I will be able to. I'll be able to check that. You can put that in the chat so that
Okay,
I can follow up with that. And yeah, I will go ahead and get the recording for this up in case you get stuck on something. You can go back and rewatch.
okay. It's oh shit.
Chat should be at the bottom right there. There you go. Excellent.
Excellent.
All righty then. I hope this was
Mm.
helpful.
No, yes, yes, yes. So much. I
Excellent.
Cyber Dojo is interesting, and I will do others exercises.
Very good.
Yeah, it's very good. It's very good.
All right. Then we will look forward to seeing you next week. And
Yes, yes.
you have a great weekend. We'll talk to you later.
Okay, you too. Thank you very much.
Sure thing. All right. Bye.
Bye, Scott. Good weekend.